Hello, let's look at Vite npm package um, and how that's used to serve front end. So we will apply to three.js and we'll also look at physics today. So we'll combine Vite, three.js, and we'll also introduce physics. All right, let's get started. Okay, so I'm going to work in this directory and I'm going to call it um, so let's say we have to npm create Vite at latest, and let's call it uh, a Vite project, then three.js and Canon physics. Okay, well, let's just start here. Yes, vanilla. Going to work with JavaScript today, and let me cd into v3.js Canon. Okay, now I'm just going to follow the instructions and do a npm install. And then I'm going to open it up in Visual Studio Code. So I won't run the server immediately. Uh, Actually, let's see what happens when I do run the server right now. So npm run dev. So we get some sort of a boiler boilerplate product app here, which has all the templating, everything, and we don't want any of it. So we delete that and we need this app here. We can change the title. Uh, so so it's very simple. So Webpack was a bit complex, and Webpack has been there forever. Projects like Vite and Parcel make it easier. Vite especially is good. Uh, Apparently, it's much faster for hot reloading, so that's why. And actually, I also like Vite quite a bit. So I'm going to leave the server running, and then I'm going to uh, npm install three.js and then Canon ES. So let's start writing the boilerplate. So import star as, so we will copy paste the boilerplate today. We won't keep writing the same thing again. Okay, so from three and import orbit O is capital, orbit controls from three examples JSM and controls, then orbit controls. Okay, so I'm just we we have done mm, the basic boilerplate multiple times. So I'm just to give you a brief introduction in case you have some doubts. So we need to have four things: scene, camera, renderer, and we need controls. Okay, and we will fill in this. I mean, so scene is equal to new three dot scene. Then we have camera is equal to new three dot perspective camera. This is the focal length, window dot inner width and inner height. So zero point 0.01 is the near and 1000 is the far. So how close and how far will the camera register objects? Renderer is new three dot WebGL renderer. and controls will be equal to new 3.orbit controls. It will take in two arguments, camera and renderer.dom element. Now we need to register the size of the renderer. So renderer.set size, and I'm going to copy this and change the division to comma. So now we have to add this renderer to the uh, HTML div, which we saw was app document dot get element by ID. So I think app dot parent child renderer dot dom element. So we have the complete renderer. Here, once we do the controls, we have to update it. Update the camera projection here. So camera dot up will be new. We want to set Z axis to uh, top. So 3.vector 30001. By default, Y is going up and Z is coming out of the screen. So here we set camera dot look at 0,0,0, and oh, by the way, we don't really need semicolons, so it is out of habit that I just keep putting semicolons at the end of the line, but in JavaScript I don't think typically we don't need to have semicolons. Actually, let me just do a Alt Shift F and format it. So camera dot up, camera dot look at, and let's set the camera position dot position, sorry, dot set the 20 20 20. So then once we have set up the camera, let's update the controls. Now we need a function called render, and we render the scene and the camera. Now we need an infinite loop. Let's call it animation loop. And here we will request animation frame, animation loop. Also render here. Finally on window resize, window resize camera dot aspect will be equal to window dot inner width divided by window divided by dot inner height. Then camera dot update projection matrix and renderer dot set size window dot inner width and window dot inner height. So we have all of this. Now we just need to call the animation loop. Okay, so I'm going to do that maybe here. Animation loop. So this much we know, and to make sure that we know that this it is being rendered appropriately, we will set the background and D will be new dot color 0x. Let's set it to some magenta, and let's okay. I won't set it to magenta. Let's just set it to gray, and let's provide an axis. Okay, let's we'll need a plane and a box right now, so we'll do that. Okay, so this is our boilerplate code that's over. Now we are going to do some physics work. So what we want to do here, first of all, we need to import Canon. So import star as Canon from Canon ES. So once we have Canon, we have to, okay, so what we want to do is let's have a plane and let's have a box, and the box will fall down due to gravity and it will bounce on the plane. Okay, so let's build that. So first of all, let's create two three.js objects. Okay, so let box body, so let's box geometry be equal to new three dot box geometry, and let's just do 1 comma 1 comma 1. Then let box mesh be equal to new 3 dot mesh, and we give a box geometry, and then we create a new 3 dot mesh basic material. We just need to give it a color. Let's make it a red box. Okay, and let's add it to the scene. Okay, so we have our box. Now let's also, okay, let's do the plane. Let plane geometry be equal to new 3 dot plane. So it won't, let's do, instead of the plane geometry, let's do a thinner box geometry, and let this be 20, 20, and 0.1. And the reason for that is if we do a plane and we develop the same plane, use the same plane in Canon, then in Canon is actually the plane is infinite. So we don't want it to be infinite. Let plane mesh be equal to new 3 dot mesh. We call it plane geometry. We have a new mesh 3 dot. I'm just going to copy it from here. Mesh basic material. It's always a good idea to copy if we can afford to do it. Okay, and we add this to the scene. Scene dot add plane mesh. This color is very bad. Okay, now it makes sense. Okay, so this is the three.js objects. Now we are going to make a parallel, let's call it a parallel world in Canon.js, where we will have the same objects, but we will assign properties to those objects, like gravity and mass and so on. So let's start with the world. So const, we have to define a world in Canon.js. So this world will have the properties that we want. So this will be new canon dot world, and this will have the property of gravity as new canon dot vec3. So gravity will act in this particular direction with a intensity of 0,0,0.9192. Let's do 9.2. Okay, so this will be our world. Then we need to provide a so let's say this plane that we have here that we are calling plane, let's make the parallel of this plane. So let's say plane. So like we have mesh in three.js, we will have body in uh, Canon. And before we develop the body, let's develop the material. So let's call the plane material as new canon dot material. That's it. Now mm, plain body will be new canon dot body, and we will give it a shape of canon dot box, and the size of this box will be the same as our object, which we will give by a vector canon dot vec3 as 20 comma 20 comma 0.1. So we have the shape. Next we need the type of the body. So this will be a static body. It will not move. It is like the earth. Body dot static. Okay. What else? And then finally we assign a material. We need to assign the material because this material will help with the, this is actually a physics material. So let me rename the material as plain phys material. So this material will have like friction and so on. Okay. So in the same way, we want to construct a box phys material, and this will just be the same canon dot material. Then we will say define the box body canon dot body. So what all do we need? We need a shape, then we need a type. We don't need a type here. We need a mass. We want this body to move, and then material. Okay. So shape will be new dot box, and this was all 111. So we will have the same 111. Then for the mass, we will just put 1, and for the material, we will use our box phys material. Okay. I think now okay, so once we have these two objects, we need to add them to the world. So just like we add meshes to the scene, we will add these bodies to the world. Okay, so mm, let's add world dot add body. And so first of all, we need to add the plain body. Okay, then we will set the rotation. Okay, so we add that. Then we also add the box to the world. Now, to take care of aspects such as angular motion or mm, friction, we should develop another overall material that will interface between the plane and the box. Okay, so let's call it const plane box contact material, contact phys material new. So this is again canon dot contact material. So now we are calling it a contact material. So underneath the inside of canon, they have all the calculations for calculating friction, and what happens when an object bumps against, how much will it bounce back against when it bumps against the ground. I mean bounces off the ground. Things like that, all that is already provided to us. So we will call so first will be the plane physics material. Then we call the box physics material. And then as a JSON, let's just start with friction as 0.4. Let's make it 0.25. Okay. Then let's uh, let's add this material to the world. So let's say world dot add contact material plain box contact physics material. Okay. So once we have all of this set up, then we will also define a time step. Okay, sorry, my caps was on. Time step will be 60 frames. We'll work with 60 frames. So this is how we define 60 frames. Uh, then in the animation loop, we have to connect the, we have to first of all say that the world will move progress with 1/60th. I mean, based on the time step, something like the frame systems in game engines like or graphics engines. So we can say that world dot step will be time step. Then we have to, oh, this is not in window resize, sorry. This will be in the animation loop. So let's put this in the animation loop. Let's do it before rendering. Okay. Uh, so we get to the world. Then plain mesh. So we will use the properties of the three.js object to set the properties, physical properties of the um, Canon bodies. So copy. So we will first of all position, we'll copy the position of the plane mesh, plane body, and then the rotation would be given by quaternion, quaternion copy plane body. Oh, I forgot to write the position here. Okay, so in the same way, box mesh dot position dot copy will be box body dot position, and we will substitute here. Okay, let's see what the error is. Vec3 is not defined in 57. New 3 time step is not defined. This is all silly typo error, so S was capital. Okay, I don't think you noticed, but the box just fell through, and that's because the box was sitting in the middle. So now I'm going up to the three.js box mesh, and I'm going to move the box. Okay, so box mesh dot position dot set 0 comma 0 comma, so let it be at a height of say 30. It's falling, still falling. Maybe we can set the position of the box somewhere here. Let's set the position of the box here. Uh, that's where the, so actually the mesh, if we deform, it won't work. It's the reverse of the mesh actually. It This the position is taken from the physics object. Okay, so this is a new canon dot vec 320. No, where is the, oh, I'm putting the plane at a height of 20, not the box. Okay, now everything is working. So sorry, my mistake. To set the position of the box body in the world, and then the three.js mesh inherits from there. Okay, and what else? So if we set the mass to set 10, okay, what else can we do? Let's do let's give it an angular uh, velocity new, not 3, sorry, canon vec 310. I think you saw it. It's rotating as it comes. So it's rotating along the z-axis. So let's make it rotate along the y-axis. Yeah, and then let's do an angular damping. This is a float. You can see the bounce is very little. So, so you can see that bounced a lot more. And if I make it 0.75, it should bounce very little. Yeah, all right. So there we have our physics and three.js working with Vite. Vite is, as you can see, much simpler to set up and start working with. So I'll put all this code in GitHub, and we in the next few, and we'll adopt this Vite and JavaScript combination. So we will now start having main 001, main 002, and so on. All right. See you. Thank you.